In this example, we are asked to factor the polynomial expression using the method factoring by grouping. Now, we tend to use this technique, factoring by grouping, when our polynomial expression has 4 terms. So let's review the strategy for this method with this example. So the first thing that we want to do with this method is to consider the first 2 terms and the last 2 terms separately. Now, when we look at these 2 terms, we want to be trying to identify the greatest common factor for each of these groups. So looking at our first group, we can see that these 2 terms have a greatest common factor of x squared. And looking at our last 2 terms, we can see that these 2 terms have the greatest common factor of -6. Now, before we move to step 2, I just want to point out that while it is common practice to use the first 2 terms and the last 2 terms, you can also try different combinations of these terms to produce a similar technique. So now that we have determined the greatest common factor in our first group and in our second group, we now want to go back to this original expression and factor the greatest common factor out of each group and proceed in simplification. I want to pause for a cause here because this is a great checkpoint for the factoring by grouping technique. Once you have factored that greatest common factor out of each group, you should be able to see a matching binomial. If you don't see this matching binomial, that means that we should probably go back and check for algebra errors, or perhaps this expression couldn't be factored. But since we do have a matching binomial here, we can take this further by factoring this greatest common factor out. So we have factored that greatest binomial out, x plus 3, and notice here that while this doesn't quite look like a perfect difference of squares, we can still rewrite this 6 so that we can produce a difference of squares formula. So if we rewrite that x squared minus 6 as x squared minus the square root of 6 squared, we can use a difference of squares formula to factor this expression completely. Now, as always, be careful. We should never assume that we are correct. You always want to make sure to check your work by multiplying this product back out. So when we multiply these terms back out, we're left with x cubed minus 6x plus 3x squared minus 18. And while it doesn't perfectly match, they are the same. They're just in slightly different orders. So if it makes you feel better, you can simply reorder the terms in this polynomial to match the given polynomial. But this multiplication has confirmed that we have factored correctly and making that our final answer.